Alright. Engineering symbol prints and drawings, Module 2. Engineering fluid and diagram prints. Table of contents, list of figures, list of table of reference, objections of the engineering fluid diagram prints, symbology, valve symbols, valve actuator, control valve designation, piping system, instrumentation, sensory devices, detector, modifier, transmitter, indicator, recorders, controllers, simple interest loops, components, miscellaneous P and ID, symbol summary, reading, engineering P and IDs, standard convention, valve status, summary, PID, print reading, example, and summary, fluid power, PID, fluid power diagram, schematic pump, actuator, reservoir, actuator, piping valves, reading fluid power, diagram type, fluid diagrams, and summary. Figure 1 valve, symbol figure 2 valve actuator, symbol 3 remotely control valve level, control valve, figure 4, figure 5 control valve position, control valve designation, 6 piping symbols, figure 8 more piping symbols, detector senses device symbols, figure 10 transmitter instrument, figure 11 indicator recorders, figure 12 controller stove, 13 single conditioner, figure 14 instrumentation system example symbols of the majority components, 15 miscellaneous symbols, 16 valve status symbols, 17 exercise P and ID, fluid power pump and compressor, 19 fluid power reservoir symbols, 20 symbols of linear actuators, 21 symbol of rotary actuators, 22 fluid power line symbol, 23 valve operation, 24 valve symbol of development, figure 25 fluid power valve symbol, 27 26 simple hydraulic power system, 27 line diagram, figure 27, figure 29 typical fluid power diagram, figure 30 pictorial fluid power diagram, figure 31 cutaway fluid power diagram, figure 32 schematic fluid power diagram. Table 1 instrument and identifiers. References. Terminal objective: given the engineering and print, read, and interpret a facility engineering piping instrument drawing enabling objects, identify the symbol using P and ID symbols following the types of valve: globe valve, gate valve, check valve, stop check valve, butterfly valve, relief valve, rupture disc, three-way valve, four-way valve, throttle, needle valve, pressure regulator. Identify these symbols using the engineering P and ID on the following types of valve indicator operators: diaphragm valve operator, motor valve operator, solenoid valve operator, piston hydraulic valve operator, hand manual valve operator, reed valve operator. Identify the symbol using the P and ID. Educators identify symbols using the P and ID following line: process, pneumatic, hydraulic, and air gas, instrument, signal, electric, instrument, capillary, and electrical. Identify the symbols used with the engineering P and ID following basic symbol instrumentation: different pressure cell with a temperature element, venture, orifice, rotor, meter, conductivity, salinity, cell, radiation detector. Identify the symbols used with the P and ID location, either local board, monitor, instrument, indicators, and controls. Identify the symbols used with the engineering P and ID following types of the instrument: signal, controller, modified, proportional, integral, differential, square root, extractors. Identify the symbols used with the engineering P and ID following system type, component, central figure pump, pipe, displacement pumps, heat exchanger, compressor, fans, tanks, filters, strainers. See how the following valve conditions depicted with the engineering P and ID: open valve, closed valve, throttle valve, combination valve, 3 to 4-way valve, lock, closed valve, locked, open valve, fail, closed valve, fail, as is valve. Give energy P and ID, identify component determinant of the flow path, give it the valve lineup, identify the symbols, give it the engineering fluid power diagrams for the following components: pump, compressor, reservoir, actuator, piping junctions, valves, given a fluid power type of the drawing, determining the operation result in action with a state component with a hydraulic pressure supplied or removed. To read and understand engineering fluid diagrams, prints usually refer to the P and ID. Individuals must be familiar with the basic symbol to identify the symbols used within engineering P and ID. Following types of valve: globe valve, gate valve, ball check valve, Symbolgy valve, butterfly valve, relief valve, rupture dial, three-way valve, four-way valve, needle valve, pressure regulator. Identify symbols used within engineering following type of diaphragm valve operator, motor, solenoid valve, piston valve opener, hand operated, man valve operator, reed rod opener. Identify symbols used with the P and ID, educators, injectors, symbols used with the P and ID following lines: the process, pneumatic, and hydraulic and air gas, instrumental, signal, electrical, instrumental, capillary, and electric. Identify symbols using the P and ID following basic type of the instrument: differential, pressure, temperature, element, venture, orifice, rotor, meter, conductor, salinity, cell, radiator, detective. Identify the symbol using the P and ID. Note the location, local board mounted instrument indicator controller. Identify the symbol using the P and ID following types of the instrument: signal, modified, proportional, integral, differential, square root, attractors. Identify the symbol using the engineer of the P and ID following types of the system: their central figure pump, power displacement pumps, heat exchanger, compressor, fans, tanks, and filters and strainers. To read and interpret the piping the instrument drawings. Piping the instrument or drawings, the reader must learn the meaning of the symbol, the chapter, discuss the common symbol that you use, the depict the flow system component of the Symbolgy is mastered. The reader will be able to interpret it. Most pipe instrumentation drawings, the reader should know that the chapter represents fluid system symbology rather than being all-inclusive symbol represented here are the most commonly engineering piping and instrument drawings. The reader may be expand his or her knowledge of the pertaining of the student appropriate drafting standards used at his or her facility. Valve symbol. The valves used with the control of the direction flow rate with the pressure fluid. Figure 1 shows the symbol of the depict with the major valve types. It should be noted with the globe of the gate valves will open with the depicted by the same valve symbol. In such case, if the information concerning the valve may be conveyed by the component identification number or by the notes or legend section of the drawing, however many instances even they may not be hold true. Shows gate valve alternative, ball valve alternative, needle valve alternatives, butterfly valve alternatives, plug, diaphragm alternative, pipe reducer, relief alternatives, three-way valve, four-way valve alternator, alternate, check valve alternatives, stop check valve alternatives, angle rupture disc alternatives, pressure regulator. Valve actuator. Some valves are provided with the actuator all remote operation to keep the mechanical advantage of both. The figure 2 shows the symbol for the common valve of actuators. Note that all the each shown or attached with the gate valve of the actuator can be attached to any type of the valve body with no actuator shown with the valve symbol that may be assumed with the valve that's equipped with a hand wheel or manual operation. So the diaphragm, and all these are gate valves, diaphragm alternative and electrical motor, solenoid alternative and piston alternative, reach rod and manual. The combination of the valve and actuator is commonly called the control valve. The control valve symbol combined with the appropriate valve symbol. The actuator symbol is illustrated in figure 2, but the control valves can be configured many different ways. That they most commonly found with the configurations are manually controlled with the actuator from a remote operation state with the automatic control with the actuator with the instrument, and both. In many cases of the remote control of the valve is accomplished by using the intermediate small control valve that operates with the actuator with the process control with the intermediate control valve with the plate for the supplying motive force to with the process with the control valve is shown in figure 3. In this example, the process air operated control is controlled by a solenoid operated wave with a three-way valve with an air supplying line. The three-way valve may be supplied with a controller valve with the diaphragm or vented with the diaphragm. Shows the solenoid over the three-way valve with the diaphragm and the pressure control valve, and then note, the symbols alone in figure 3 do not provide with the reader with enough information to determine the applying pressure of the diaphragm opens with closed with the pressure control valve, the energy of the solenoid pressure with the vents of the diaphragm. Further, figure 3 is incomplete in that it does not show the electrical proportion of the valve control symbol, nor does it identify the source of the motive force compressed air. Although figure 3 informs the reader with the type of the mechanical components of the control system, how they interconnect, it does not provide with enough information to determine how the components reach to a control symbol. The control valve is operated with the instrument and signal with the symbol with the chain man with the shown with the previously except with the output with the control of the instrument go to with the valve. The actuator figure 4 shows the level of the instrument designated to LC with the control of the level and the tank of the positioning of the air operated with the diaphragm control valve. Again, note with the figure 4 does not contain enough information to enable the reader to determine how the control valve responds to change in level. Alright, it shows the tank and the level controller with the air source and lever controller valve with the diaphragm solenoid. Additional aspects: some of the control valve with the valve positioner allowed with the precise control valve, especially useful with the instrumentation signal with you with the control valve. With the example, the valve positioner set limit switches operated with the motion of the valve. The positioner symbolized with the square box of the stem of the control valve action with the positioner. They may have lines attached with the motive force instrument signal both. Figure 5 showed with the two examples of the valves equipped in the positioner. Note that all these examples are more detailed, thus the figure in 3 and 4 readers still do not have sufficient information to fully determine the response of the control valve to the chain with the control signal. Figure 5 showed the control valve with the valve positioner, showed the solenoid and the starter valve with the air going from the I don't know what the dashes are, limited control valve, and then the valve positioners. Examples in Figure A. Example A in Figure 5 with the reader readily assumes the opening solenoid control valve sum of the proportional level of the control solenoid valve provides override over the automatic control symbol. However, the reader cannot ascertain the open and close of the control valve. Also, the reader cannot determine the direction of the valve move with the response to change in the control parameter. Example B, Figure 5 can make the same general assumption with Example A with the control signal is unknown with additional information from the reader can only assume with the air supply provided with the both control signal, motive force, and motive force on position of the control valve. Even when the valves are equipped with the position symbol may appear with a detailed symbol of the diagram. Larger overall symbol of the diagrams usually do not show how much the detail may only show. With example, the Figure 5 of the air operated with no special feature for the control valve designations. Control valve formation for the number of the function for the fluid symbol, the differential between the valve with the balloon labeling system identified with the function of the control valve is shown in Figure 6 with the common convention of the first letter used in the valve with the designator indicates the parameter of the control for the valve. For example, show the diaphragm flow control valve, which is gate valve, temperature control valve with the motor with the temperature control valve parameter, level control valve, pressure control valve, and hand manually operated valve. The second letter is usually C. Identified with the valve of the controller active with the component is used with the hand operated, but the third letter V indicates the piece of the equipment is a valve. Piping system. The piping signal system may be obtained with a more than single medium. For example, although the main profitable flow line may carry with the water associated with auxiliary piping may carry with the compressed air, near gas, hydraulic fluid, adds of the fluid system diagram may also depict with the instrument signal with the electrical wires also with the piping. Figure 7. Commonly with the symbol that indicate with the medium carried by the piping for the differential between the piping and the instrumental signal with the electrical wire with note that although with the electrical auxiliary piping system identified with the medium symbol of the process flow line does not identify with the medium of the diagram may also depict with the individual fitting with the compressing of the piping run depending on the intended use. Figure 8 show with the symbol with the depict the pipe fittings. First we show the process flow line, the pneumatic air line with the defining the process which have the two dashes in line, hydraulic line, a short and a long dash, and then alternative would be a short with L's crossed out crossing the line. In air gas, single dash instead of double dash, single crosshairs. Instrument signals, small dashes. Instrument capacitor X's dashed. Electrical wire dot dash. Alternative smaller dashes. Electrical heat tracing, straight line with the E's on the dash, and steam heating tracing S on the dash line. The diagram also may depict an individual fitting of the pressing of the piping run depending on the intended of the Figure 8 show of the symbol you depict the pipe fittings. A ductor show of the one large concave and then two J grooves, ejector concave and then one J groove to the left and smaller. A pipe producer is a small cone. Hose connection is a bracket, ended bracket, flexible joint with the parallel lines inside with a flexible convex removable spool, double dash period, crosshairs lateral Y or Y crosshairs, true Y crosshairs, blank flange, double blank, only one-sided parallel lines. Union screw, two long, one narrow flange, two parallel lines. Instrumentation. One of the main purposes of the piping and instrument drawings is to provide functional information about how the instrumentation system will piece of equipment interface simple with the piece of equipment because of the large amount of the symbology appearing with the parent pipe and the instrument drawing to depict with the instrumentation loop. Symbols used for the reference of the individual instruments for their loops could be divided into four categories. Generally, each of these four categories used for the component identified with labeling scheme identified in the table of 1. First column, table of 1, lists of the letters used identified with the parameter being sensed with the monitored by the loop or instrument. Second column, list of the letters used indicated with the type of the indicator or control. The third column, list of the letters used indicated with the type of the component. With the fourth column, the letters used indicated with the type of the signal that are being modified by a modifier. Alright, table 1, instrument identified with the sense parameters F flow, T temperature, P pressure, I current, L level, V voltage, Z position, type of indicator for control, R for the recorder, I indicator, C for control, type of the component transmitter, M for modifier, E for element, type of the signal, I for current, V for voltage, P for pneumatic. These first three columns are above the combined with the result of the instrument identified with the indicated sense parameter of the function instrument with the type of the instrument. The fourth columns are usually only of the K for the instrument modifiers, U for the indicator with the type of the signal being modified. Following a list of example of the instrument identifier constructed in table 1, FIC flow indicator control, FM flow modifier, PM pressure modifier, the TE temperature element, TR temperature recorder, LIC level indicator, case controller, TT temperature transmitter, PT pressure transmitter, FE flow element, F flow indicator, FI, TI temperature indicator, FC flow controller. Sensing device with the detector with the permanent any system with a modified with the indicator with the control with the both the create with the usual signal with the device that must be inserted into the system with the tech with the desired parameter. In some case with the device U with the create with the special conditions so with another device supplied with the necessary measurement. Figure 9 show with the symbol used for various sensor and detectors. Alright, you have your orifice and alternative, and then that venture with what looks like a restriction. A flow element, which is given in with a restrictor and a orifice with a bulb with the FE, with the labeled FE temperature element. Junction without well with well, TE in the circle, thermal couple, TC on a bulb, rotary motor, triangle with a square in it, pressure differential pressure cell. Large box, lower box, or PE for pressure cell, conductive cell, shows radiation detector. Modifier transmitter. Sensor for the detector for itself with a non-sufficient create with a usable system with an indication that each sensor for the detector must be coupled with appropriate modifiers or transmitter with the exception. Certain type of the local instrument have with the mechanical readout. So for the burden tube, pressure gauge with the bimetallic thermometer. Figure 9 illustrates the various examples of a modifier transmitter. Figure 10 also illustrates common notation indicate with the location of the instrument, local border mount, transmission. You with the signal with the sensor for the detector with the form to be sent with the remote control, remote port for process controlling mounting output could be in electronic voltage or current with the pneumatic and hydraulic. Figure 10 illustrates the symbol of the server, the specific type of the transmitter. Readers should note that the modifiers may only be identified with the type of the input, with the output, and such for the IP with the converts for the electrical inputs for the pneumatic output, rather than be modified to the pressure parameters, such as PM with the pressure modifier. Alright, figure 10 is your transmitter and instruments. Basic symbols you have a locally mounted instrument, boarded mounted instrument, instrument behind board. Example of the modifier, locally modified voltage current flow and show the EI or volts over the amps, the flow modifier in 2 to 3 different structures, circles and squares. Locally mounted pneumatic current pressure modifier P over I or PM or pressure over in the I. Electric voltage locally mounted square root extractor, circle and the square root sign. Example of the transmitter flow show the restriction or venture, and FT flow transmitter and pressure transmitter also with a bulb to the T junction. Indicator recorder. The indicator recorder's instrument with the first signal generated with the instrument loop with a readable form of the indicator recorder may be locally boarded with a bound of light modified with the transmitter information indicated within the type of the symbol that U of the figure 11 that provides example of the symbols U with an indicator of the recorder, how the location is denoted. Controllers process the signal from the instrumentation loop with the position manipulate some of the other system component, but generally is denoted with the placing a C in the balloon with the after with the controlling parameters shown with figure 12 with their air. Controls that serve the process with the signal to create with the new signal that include with the proportional control, the proportional integral controllers with the proportional and trickle differential controllers, and similarly with the controllers are those figured in 13. Note that the system of the type of the controllers are also called signal conditioners. Figure 11 shows your indicator recorder shows the locally mounted flow with the venture and the restriction is FI bulbs mounted temperature, the TI and pressure indicator PI mounted board flow indicator flash board measure pressure indicator flow recorder mounted behind board, locally mounted temperature recorder, locally mounted pressure recorder. Flow controller with the C's in the bulbs, so the flow controller, temperature controller, pressure controller, and level control with the proportional pressure, integral, proportional, integral, control, the differential, and current to pneumatic. Example of the simple instrument loops of the figure 14 show the two examples of the simple instrument loop of the figure 14a show the temperature transmitted with the generator of the two electrical signal the one signal go over the board mounted temperature of the recorder of the display signal of the proportional integral derivative of the controller of the output which for the set of the currents of the pneumatic modifier of the current to magnetic pneumatic modifier of the electrical signal of the converter of the pneumatic signal with commonly 3 psi out of 15 psi for the turns operated for the valve function for the complete with the loop with the modified flow based on process fluid temperature to know whether there's not enough information to determine how the fluid with the temperature is related same with the set of the point, some with the inside of the set point and stay within piping an instrument drawing. Knowing the set point of the purpose of the system usually be sufficient to allow the operation of the instrumentation loop to be determined. Figure 14 show the instrumentation system example. Figure A show the temperature transmitter, pressure indicator, detention, and pressure indicator modifier, diaphragm, bake valve, and then that's dash line, and then temperature recorder. Figure B show the tank of the load level temperature. Alright, the output level transmitter level, the modifier level, recorder, gate valves, pneumatic level of the transmitter illustrated in figure 14 sense for the tank level, the output of the level of the transmitter, pneumatic route of the board mount for the level of the modifier, level modifier condition, signal possibly removed for the mechanical modifier for the signal, you with the modified signal for the two purposes of the modified drive of the board mounted, record with the indication sent for the modified pneumatic signal with the diaphragm operator level of the control valve. Note the insufficient operation exists to determine the relationship between the tank level and the valve operation components. When every fluid system there are more major components such as the pump of the tank of the heat, the exchange, fan, figure 15 show the engineering symbol the most common of the major components. Central figure pump, alternatives and submersible, pipe of displacement, reciprocating or alternative rotary, fan, central figure, heat exchanger, and or alternatives, compressor or alternative, central figure fan, van axle, propeller, tank, and then and strainer. Symbols for major components. Miscellaneous pipe of the instrument diagram, drawing symbol with the addition with a normal symbol of the pipe of the instrument drawing with a representative specific place for the equipment of their miscellaneous symbol for the guide with the provide with additional information about the drawing. Figure 16 lists and explain four more of the common miscellaneous systems. Show the piping wire continue with the drawing with the XO00 with the grid with the coordinate with the X and Y flows into that drawing with the pipe of the wire continue with the from of the XX002 grid XY flows into the drawing. Pipe of the wires continue with the drawing with the XX003 coordinate X and Y flows in both directions and building an area boundary. Summary with the information in this chapter summarized below with the engineering fluid the diagram summary with the chapter the common symbol the piping the instrument drawing valve of the valve operated with the pipe instrumentation common system components were reviewed. Alright, chain conventions have been developed to provide consistency with the drawing accurately interpret the drawing with the chain of the convention but must be understood. Standard show the open and close valve with a combination valve 3-way to 4-way, lock, close, lock, open, fail, close, fail as is valve. Standard convention for the valve step before the diagram print with the properly read with the understand basic conventions of the using piping the instrument drawing to denote valve's position. Valve failure modes must be understood, but the reader must be able to determine the valve with the position, know the position of the normal to know how the valve with the fail with the some case know the valve with the normally locked in position. Figure 17 illustrates the symbol that you would indicate the valve status unless the otherwise piping the instrument diagram drawing indicates the valve with the normal position of the is usually interpreted with the normal or primary flow of the system and the exemption of the safety system with the normally shown with a standby or non-accident condition. Show the closed valve with the full end gate colored gate valve, open one with a not full cut as draw no fill big butterfly valve, throttle valve symbol, half filled butterfly valve, locked open, empty, non-filled LO butterfly valve, lock closed, filled in butterfly valve, LC valve fails open, plain butterfly valve FO fail closed. Valve plain butterfly FC fail as is F plain butterfly FAI 3-way valve and one port open and one closed shows the square T junction 3-way valve with the gate closed and the filled. Three-way valve sometimes drawn with a position failed, but instead always been drawn with a normal position, even if defined with the standard by the system of the drawings drawn the some name of the individual drawings. Some of the important information for the chapter summary of the reading and engineering with the piping instrument diagram. Summary of the chapter review of the basic symbol of the common standard of the convention of the piping instrument drawing, such as the valve condition modes of the failure of the information symbology learned of the preceding chapter, provides information necessary for the read of the interpret the piping instrument drawings. Pipe and instrument drawing reading example to give the engineering of the pipe and instrument drawing with identify the components determine the flow path of given the valve lineup example. At this point, all the symbol of the valve with the major components have been presented. Have the convention of identify the condition of the system. Refer to figure 18. F the area answer for the following question. Answer for the provided in the back of the section as you may judge with your own knowledge level. Alright, so it's 12 and 13 is butterfly valve, the adjustable butterfly on GH and I is 24 and 5, and then we have a solenoid butterfly valve on 11 and 12, reducer pneumatic temperature butterfly valves, D, I don't know what that is. Restriction orifices, flow temperature, flow control, and pneumatic pressure. Three-way valve, fail as is motor, electric, big gate valve, air compressor, E, probably some kind of tank. Identify with the following components: central fecal pump, the heat exchange of the 10th, the venture of the ruptured valve, the leaf, motor operated, air operated throughout valve, conductive cell, airline, pneumatic control, pneumatic converter with the check valve lock, closed valve lock to open, solenoid valve, control parameter, valve being 10 and 12, with the valve need with the chamber, the position of the pump beat, it's supplied with the valve flow to options G and H, which the valve fail, the open fail, closed fail is, and then show the answers. Summary information in the chapter summarized below with the prompt piping instrument drawing with the print reading examples shown with the trumper each provided with a student with example applying with the material learned in chapters 1 and 2. Fluid powergrams, piping instrument diagram with the fluid power diagram schematic required an independent review because of the unique set of the symbol convention. Identify the symbol of the engineering fluid power drawings filled with the following components for the pump, compressor, reservoir, actuator, piping junction, valve with given the fluid power type of the drawing to determine the operation result with the actuated state of the component with the hydraulic pressure is applied and removed. Fluid power diagram schematic with different symbology for the dealing with the system with the operating with the fluid power include with the gas such as the air with the hydraulic such as the water and oil motive media. Some of the symbols may be the fluid power system the same, and the similar to those already discussed, the many entirely different. Fluid power system divided into 5 basic parts: pumps, reservoirs, actuators, valves, and lines. Pumps is broad area with the fluid pump, with the 2 categories with the pumps, depending on the mode, with the media, with the being hydraulic, pneumatic. Basic symbol of the pump is circle containing with 1 or more arrowheads indicating the direction of the flow points with the arrow with the contact with the stroke with the hydraulic puncture show with the solid arrowheads. Pneumatic compressors are represented with the hollow arrowheads. Figure 9 show the common symbol that you with the pumps, hydraulic air and compressor, pneumatic, and fluid with the power diagram. Show the hydraulic pump with a filled solid fixed displacement, pump signal, variable displacement, and those are hydraulic, compressor, fixed displacement as a pneumatic. Reservoirs provide the location of the storage mode of media with the hydraulic fluid with the compressed gas, although the symbol represented with the reservoir with the wide lead with the game with the convention you would indicate how the reservoir fluid handle fluid with the mag with the reservoir usually simple tank symbology usually some of the variations of the cylinder shown in figure 20 with the hydraulic reservoir can be much more complex in terms of the fluid emitted with the removed from the tank with the convey with the information symbolic convention have been developed. These symbols are shown in figure 20 show the reservoir open reservoir with the connecting line above the level invented. Reservoir pressurized reservoir with the connection lines below the fluid level. Reservoir connection lines above fluid level. Level lines with below the reservoir only with essential for the circuit function and receiver for air or gases. Pneumatic symbols. Figure 20 was the fluid power reservoir symbol. The actuators within the fluid power system, the device for the converts for the hydraulic, pneumatic pressure, and mechanical work for the actuator classified by the linear actuator, rotary actuator. Linear actuators have some of the form of the position device. Figure 21 illustrates several types of the linear action following the drawing symbols. Alright, pictorial, single acting cylinder force illustration, drawing symbol. This one has a spring to it as well as the portrait with a force illustration, drawing symbol. Double action differential cylinder, equal force both sides piston. Show the double port on the acting cylinder, forces, and drawing symbol. Double acting differential cylinder, more force exerted against the face of the other side of the piston. So the pictorial drawing symbol. This one was both equal force. This one's more exerted against the face of the other piston. Rotary actually generally called for the motor may be depicted with the variable. Some of the most common rotary symbols shown in Figure 22 show note the similar between the rotary motor symbol of Figure 22 with the pump symbol shown in Figure 19, with the difference between them in pointing with the arrow touched with the circle in the pump, tail with the arrow touched with the circle in the motor. Show the motor fixed displacement and hydraulic motor variable displacement, and fit with hydraulic motor oscillation. Double symbol of the rotary actuators. Piping. The sole purpose of the piping fluid power system transports working meteor to pressure for the 1.2 with another symbol of the various line with a termination point shown in Figure 22. Alright, first you have a line and then a large gap would be line plotting, and a single regular dash would be the line drain. Connector dot to be fixed with widths, and line fix is a curve with a connector dot line join. Is cross lines with dot that are connectors, line crossing or leaps and spaces, or direction flow showed by the arrowhead. Line above the fluid level is above the tank. Below the fluid level touches the bottom of the tank. Line vented manifold shows the concave line over the tank. Plug connection X. Testing station gauge connecting show over the X and T and S. Power takeoff hydraulic P and a T and L over the X. Restricted fix venture and variable restriction venture. Strainer is a diamond with a double dash with a single dash across in the middle of it. Valves are the most commonly symbols of the fluid, most complicated of the symbols in fluid power system. Valves provide with the control of the required to ensure the mode media with the routed to the correct point when needed. Fluid power system diagrams require much more complex valve with the symbol of the same with the probing instrument drawing due to the complicated valve used with the fluid power system. The type of the pumping instrument drawing valve opens closes. The valve with the process of fluids, but if the rarely required for the process of the fluid, any complex man with a 3 or 4 way valve with the common expectation in fluid power system. The common end valve with the 3 to 8 pipes attached with the valve body, with the valve being capable of the rotating fluid, several separate fluids. Remember the combination input-output flow path. The symbol as used to represent the fluid power valves most contain much of the information. Same piping and instrument drawings. Valve symbol to meet this need with the valve symbology shown with the following figures. Developed with the fluid with the power instrument drawing. Figure 24 cutaway valve with the provided example of internal complexity with the symbol of fluid power with the type of the valve. Figure 24 illustrates the 4-way valve, 3-position valve with how it would be operated. Married with the fluid with a note with the figure 24 operated with the valve with the 9 identified with the same process with the fluid valve with the valve can be operated with the diaphragm. Motor hydraulic solenoid manual operated with the fluid power valves with electrically operated with the solenoid or drawn with a de-energized position. Energized with the solenoid will cause the valve to shift the other port. If the valve is operated by any other solenoid, the multi-valve with the information necessary to determine how the valve operates for the provided with each of the drawing accompanying alleged print. Alright, show for the pressure. Cylinder, and then a 4-way, 3-way. Show for the 4-way, 3-position valves in C. Pressure inlet position A, 1, 2, pressure 1, tank 2 exhaust is with a T. Pressure inlet 1, tank 1 and 2. Pressure inlet 1 and 2 to tank or exhaust. So that's a valve operation for your valve operation. Figure 25 show the valve with the figure 24 transforming and usable. Show with the start with the basic symbol of the envelope for a valve. Step number 2, add the ports of the opening symbol even though the pictorial show 3 ports. The top of the valve, place 2 on the top and 2 on the bottom. So pictorial, this shows the right 1 on the top, 2 on the place 2 on the top and 2 on the bottom. Do not place 2 and then 3 on the top of the 1 on the bottom. That shows the flow in all 3 positions. Show 1 to 1, P to 2, and then position closed, and then position C, which would be 1 to T, 2 to P, and then closed. Then you have all 3 positions. So that shows the three positions of your of the valve. Add an actuating mechanism into the case. The valve manually activated in one direction, spring activated in the other. And now you have the combined all elements single system, and that was valve symbol development. So you have the middle close, O position C and position A. And now you have your figure 25. Figure 26 shows the various type of the valves, even the fluid, valve check, valve manual shut off, valve maximum pressure release. Show the spring valve, the arrow to the side relief, valve basic symbol flow path, the envelope, basic symbol multiple flow path, envelope, valve single flow path normally closed, arrow to noted to the left, single open would be arrow in the middle, valve multiple flow blocked as valve multiple flow 1 open arrows denote the direction of the flow. Valve direction 2 position connections, 2 position 3 connections. Valve direction 3 positions, 4 connections. Open center. I'm not sure if I understand that one, but valve direction 3 positions, 4 connections, closed center. Alright, reading fluid diagrams. Use the Symbolgy previously discussed when the fluid power diagram can now read. Before reading some of the complex example, look at the simple hydraulic system converted into the fluid power diagram. Using the drawing with the figure 27 on the left of the portion, figure 28 lists of each of the power fluid power symbol on the right side of the figure 28 show the fluid power diagram represented the drawing of figure 27 on the pump with the hose, nozzle in the well, fluid injector for the nozzle, pump fixed displacement, line working, line flexible, open reserve line connection below the fluid level, show the level of the well with the pipe of the pump of the lever, hose, and fluid injector nozzle. When understanding the principles involved with reading fluid power diagram, any diagram interpreted in figure 29 show the diagram kind of the diaphragm and likely to be encountered with the engineering field. To read each of the diagrams step by step interpretation happening to the system will be represented. Alright, it shows PB1 with a dash line to solenoid 1, and then that's spring on that's a solenoid rod on one, and spring on the other, and it's got it's 2 envelope, 2 position, 4-way. 4 position. Let me check that again. Like it was only a page ago. Alright, so we have 2 elements, spring element, a cylinder A, pressure relief valve into a bottom of the tank, temperature, and gate valve, rotary motor, filter in a well. First step to get an overview of what happened in the arrows between A and B. A low right-hand color indicate the system is designed to press clamp sometime in the part between 2 sections of the machine. Hydraulic system often need the press to work. Other application workpiece must be held in place. With the basic function, understand the detailed step of the diaphragm accomplished by the step of analysis. Even the normal local area program. Local area number 1, system open reservoir with the strainer. You have to clean the oil before it enters the system. Local area number 2, fixed displacement pump with electrically operated with the pump provides hydraulic pressure to the system. Local area number 3. System for relief valve with a separate pressure gauge for the relief valve with the spring when the operator protect the system when the overpressurization. Also acts for the underload of the relief valve pressure for the cylinder is not in operation when the system pressure exceeds the set point when the valve opens to return the hydraulic fluid back to the reservoir of the page provided with the reading of how much pressure within the system. Localized area number 4. Composite symbol of the 4-way position 2 position valve. Push button P1 is used to activate the engineering solenoid with the note the valve is shown with the de-energized position. As shown, a high-pressure hydraulic system is being arrived with port 1 and 3 within the bottom of the chamber in the position of the drive and the hole of the piston, local area 5 of the retracted position. When the position is fully retracted, hydraulic pressure builds to the unrelief of the valve with the lift to maintain the system pressure of the set point. The push button 1 is pushed by the solenoid 1 engine out of the ports 1 and 2 with the line with the ports 3 and 4 with the line with the all hydraulic fluid into the top of the chamber with the position with the drive with the down fluid at the bottom of the chamber with the drain with the 3 to 4 ports back into the reservoir with the pistons will continue to travel down. Push button 1 is relief and the full travel is relief at which at the time point the unloaded relief valve will lift. Local area number 5, the actuating cylinder and piston with the cylinder of the design to receive the fluid and either the upper or lower chamber. The system of the design to settle with the pressure. Apply with the top of the chamber, the bottom of the chamber is lined with the drain back to the reservoir with the drains. Pressure is applied with the bottom chamber, the top of the chamber is lined with the drains back to the reservoir. Types of fluid power diagrams. Some of the kind of the diagrams can be used to show how the system works. Rather than understanding how to interpret the figure 29, reader will be able to interpret all of the drawings and show the pictorial diagram, show the physical arrangement of the elements and system of the component of the outline diagram, show the external type of each of the shape of each item. Pictorial drawings do not show the internal function of the elements are not especially valid with the maintenance of the troubleshooting. Figure 30 shows the pictorial diagram of the system. So A would be a reservoir, B with an electric motor, C a pump, and then D would be maximum pressure relief valve, and then E would be directional valve into which is known as F the flow control valve, or G the right angle check valve, and then H into the cylinder. A cutaway diagram shows both the physical arrangement, operation, differential component with generally used the instrumentation, instructional purpose of the with explain with the function showing how much in system is design range. Because these diagrams require so much space, there must be not only with the complicated system. Figure 31 show the system representing the figure 30 with the cutaway diagram format illustrate similarity and difference between the two types of the diagram. Show G, the right angle check valve, the F flow control valve in and out, with the H of the cylinder, and then driving from E, the directional valve, with the B, D, the maximum relief pressure, C, the pump, B, the electric motor, and A is the reservoir. A schematic diagram using symbols show the elements. A symbol schematics are designed and supplied by the functional information system that accurately represent the relative of the function of the components. Schematics are useful in the maintenance of the work, understanding the important part of the troubleshooting. Figure 22 schematic diagram system illustrating figure 30 and 31. So motor B and C will be electrical control motor. D release pressure valve into the tank. Below the tank's valve with a spring. Flow goes into before you get into the electric motor. There's an air filter in the A reservoir. H is a cylinder. G is a check valve. F is a restriction adjustable restrictor. E is a three-way three-position three-position four-way port with control rod. Some of the important information in this chapter is summarized below. The chapter review of the most commonly used symbol fluid power diagram, basic standard convention of the reading and interpreting flowing power diagrams. And this was Engineering Symbols Drawings in Module 2 Engineering Fluid Diagram Prints.